Janos, are you here?
Yes, 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 I am.
Cool. Well, up to you. I will stop sharing my screen.
Yeah, hello. So we come to the part, the practical part of this talk, and where we are going to run our swarm nodes. And as we all know, we are all contributing to the open source. So we will start with the source of the B node. And I will share my screen. Do you see my screen, my browser currently?
Yes, I see. And the idea is that here everybody joins you, right?
Yeah. So
Yeah.
first, we are going to not to trust anything, and we are going to build our node by ourselves from the code here. There is another reason for that. Because we have the latest release 28 days ago, and since then we added a bunch of new features that will be actually released today. So version 0.3 will be released today, and we will be using the master to build our node and to have all the cutting edge cutting edge features. You can also see that we have a link to the documentation. This is the documentation for the previous release, and I have locally here running the up-to-date documentation. But you can also go to this repository and build and run your own documentation. It is pretty straightforward, but I already have that covered here running, and I will share important information with you here. To build our to install from source, we will need the Go compiler, Git tool, and make, which is actually optional for anyone that has a problem with this, so not to install or cannot install or would not like to have that executed. We will provide during this demo binaries. So I will actually upload the latest binaries, and you will be able to run your own node. So let's go. You can go, and where is the chat here?
I posted the links to the eVesphere B and eVesphere B docs already in the chat.
Yeah. So cool. So if you don't have Golang, you can download here and install. Also Git, and I will while you are preparing, I will just clone the code.
Janos, one question.
Yeah,
The B docs gets a 4 of 4. The repo is not public?
the repo should be public.
Okay, so maybe you can link this one.
Yeah. So
Okay.
yeah, this is the renamed repo. This is
Okay,
the
so
new
my
one.
mistake then. Yo.
So this is the correct link, and we will clone this
And by the way, if you're having a question while Janos is working, Janos can't see the chat, but I will see. So please feel free to put up your hand and I'll try and interrupt Janos if possible. Yeah.
Yeah, that would be ideal. So interrupt as soon as possible. And we can execute a simple command, make binary, and we will build the binary for the current operating system and architecture. It will be built in here. So it's there, and you can look at the documentation, make binary, and we will right away copy it to our path so that we have that installed. Okay, and just to make sure that we are running that binary that we just copied. So when we install some tool, we can just run it, and by default presents the usage, and this is these are commands that we can run. We can start our node, check the version, print configuration. So not much, but start is the most important. Let's check the version. So, and let's get out from this directory. So we have our version. We are prepared for 0.3, and this is the current git commit, just to validate that we are running with this state of the code. I will paste that in chat, and yeah. So actually, so there is a question about Go version. We support only 1.14 and 1.15, which are actually upstream, which have upstream support from Go compiler development, and you would need at least 1.14 to be able to compile the code. And yeah, so we checked the version. We can then check what are our configuration options, because if we start our node, we will connect to the boot node, which is the main cluster, with network ID 1. Because our main cluster, main network, works with the release 0.2, at least for a few hours more. We set up a dedicated cluster for this workshop with the latest master installed there, so that we can all connect and run the latest features. I will go. Yeah.
We got one question from Personium project asking, the binary file is for Windows 10 ?
The binary file is the binary file is for the architecture that your operating system is.
Yeah, exactly. So if you are running Windows 10 and you do make binary, then it spits out the binary for the OS that you're having.
Yeah, but it should be byte compatible with other Windows, older Windows also. So we will produce the binary which should work on 8 or 7 and yeah, yeah. If you have any problems, just write, and we can jump on it to see how to run. And yeah, so we have a bunch of options there. I will just point to the most important ones. So we have addresses to listen. So this will actually this specifies the address for the main API, B main API, which is by default on 8080. We have debug API address. This is the API for inspecting the B internals. And it has to be explicitly enabled because it should not be exposed outside of your node, because it allows for some malicious work by third parties, and this we have to be careful with that. We have network ID, which is very important now, because network ID 1 is for the public cluster, the main network. We have P2P address, and the P2P address is the address on which P2P listener will be started in order to communicate with other nodes. And actually, this is the main application interface. Debug API is the operator's interface for the application, and P2P address or P2P listener is just for node-to-node communication. We will actually not use this API at all. By default now swap is enabled, but we will disable it for this cluster. Just not to go into the incentives right now.
So what is swap, Janos? Is for those who don't know, very brief.
Yeah, so swap is the first step to incentivization. So bandwidth incentives part, and we will see if we can cover it by the end of this talk. And there is another useful, nice to have variable defined is welcome message. This is the welcome message from one node to another, and you will see in the in log messages these welcome messages from other nodes.
Janos, I have one person who is putting on the hands. I don't know if some of the presenters can give him the mic. I for some reason can't. Yep, you can talk, please. New script, you can unmute. No, you can unmute yourself. 1, 2, 3. Okay, please continue, Janos.
Yeah, thanks. So, I think that this is just enough for start. You can look at the configuration options in the documentation, but I wanted to go through most important one. So another thing, you can provide configuration with command line arguments, with environment variables, and the configuration file, and their names are all in a relation, and you can look that up here, not to spend too much time on that. I prepared one configuration file for this workshop that can be used by you. and that can be that should be adjusted a bit, and I will do that right now. So I will share this this link with you, and you can save it to your disk. So I'm in the workshop directory. I will use this command. Oh, so I will download this to the workshop, and have this here. So what I set is the boot node address. So what is the boot node? Boot node is the node in the network that will share information about connectivity to other nodes. So they are addresses so that we can join the network. This boot node can be any address of the it can be address of the any node in the network. So we will just use the one that we set up, and it is in some way a way of centralization, but actually we do not need to have this defined for the on the cluster that is running internally on our infrastructure. You can use you can ask for any of your peers to get the address, P2P address, in order to set it as the boot node and join the network. So the only trust that you would need to give is that the person you ask for is running the node that you can rely on. We will use this network ID 2809, which is current date for this network. We will define a data dir. You can set it to whatever directory that you want. I'm just using my TMP. And all of the state, so all the chunks, all the information about other peers, and all meta information that we need to keep for Swarm node to run will be stored there. And also, very important, by default, for now, keys, private keys of your nodes will be stored there. We will enable debug API in order to inspect. I've just set this password here for convenience, but you should be careful with storing your password. Given that this is the temporary network, it is okay. But if you don't set the password here, you will be prompted to enter it every time when you start your bnode. I am setting verbosity to trace because I want to see all of logs, which may be quite a lot, but for a demo, it can be useful for you to see what is going on. As I said, we will disable swap, and we will set some nice message. So I will just amend a few things there in order to, I will from, so that you can see that you are connected from to my node. And that's it. Then I will run b start and provide workshop like this. And we are starting our node. We have the possibility to use NAT for better connectivity. This is why we waited here to discover a possible NAT by our local router. Before that, we created a private key and derived the network address. This is called the overlay address. So this is the address of our node in the network. We have the public key of our node, and we are sharing this underlay addresses. So underlay addresses is are P2P addresses that other nodes can connect. And you can see that these free nodes are actually not possible to connect to because they are in the private network. But NAT manager managed to open a hole in our router, so that others can connect to my node. So if I now share to you with my node address, this one, and you set it as the boot node, you will be able to connect. And you can see that after that, we are starting our API listener, debug listener, and we started to connect to our to the nodes in the network. And we are actually seeing the welcome messages from the nodes in the network. This is the default network the welcome message in the public cluster. And we have and we are running. So as you see, I connected to Attila's node already. He is so let's see if there are other, yeah, from Goran. So this is very nice. And let's leave the node running. We will now just look what our connectivity is. So we have our debug API, and we can go to the API reference, debug API reference, that we can look at what we can see. Connectivity, a bunch of endpoints there, inspecting balances, checkbook, validating some things around chunks, status, settlements, but we are now interested in connectivity. I just want to share to show to you that we have OpenAPI documentation for these endpoints. And that you can browse, but for now I will just type some HTTP request here. So 6060, and I will just check my addresses. Oops, let's pipe to JQ. And you can see that this is the overlay, underlay addresses, and public key. You don't have to parse logs to get those. You can get this. And here's.
Janos, I have a personal question about the public key.
Yeah.
Is this my Ethereum address? Can I use this one also to interact in the Ethereum blockchain or not?
No. This is just a serialized public key. Ethereum address is derived by hashing this data, so it is actually a different array of bytes. We actually, so just a spoiler, public key can be used in communication to target PSS messages and encrypt them for specific recipients. but let's not go into there right now. But it has its purpose. So these are my peers, but the list is does not say so much. So we have the topology endpoint, which provides a bit more information. So this is the topology in the debug API, the same address. We have the population of 12 nodes. At least I am aware of that. So my boot node communicated the information about 12 nodes, and all other nodes gossiped this information. So I am connected to 10 of them. For various reasons. One may be that it is just enough to construct a healthy Kademlia. And we have here Kademlia beans. So we are categorizing our nodes into beans by their proximity. So you can see that most further nodes are there, and then as we go to the bin 5, this is the closest node that I know about. So this is my neighborhood, and not to go too much in theory there. This is just something that I wanted to show to you, that how we are connected to the network. And we are dealing the overlay address. So these are swarm addresses here. We do not expose here underlay addresses, which are P2P layered addresses. Okay, so now we would like to share some files. And you can, for example, for any of you that are using macOS and did not want to build B, I can upload that binary. So I can use the API, which is files API, and I can use this is the multi-part form upload with curl, and dist no b dist b, and I am actually submitting a file with multi-part encoding to the files endpoint as the post request. And we can look at the logs where we actually, yeah.
I have one question. This question is from Victor Todd, saying, which port should I open on my firewall for a swarm connection with the other nodes?
You actually don't have to do that. So you do not have to be exposed in order to be connected to networks, to the network. You can connect to other nodes which are actually exposed already. But if you would like to have better connectivity, you can open port 7070 from your computer on your router to be accessible by other nodes. So in that case, your node will be advertised with that underlay address for other nodes to connect, but it is not required. You can connect to other nodes, but none of other nodes will be able to connect to you if you don't do that. So I see that there is a Q&A question. So yeah, Yeah, so this means that one of the protocol has a problem delivering a chunk to its destination. I also see this, and it may be due to some network problems. There are a lot of things that can happen there. So a node, this peer, which is actually probably my peer, is it? I think that this looks like me. Got a problem to store. Maybe because I'm now uploading this file, so we can investigate on that, but we can keep the network alive for the few days, and that's that's not a problem. So to get back to our to our upload, we did upload a larger file, and it needs to. So my node, I uploaded a file to my node, and my node needs to push these chunks. So first, my file is splitted into chunks, and every chunk has address like this one, and every chunk can be measured by proximity to other to the nodes in the network. Addresses of the chunk and addresses of the nodes are in the same form, so they are the same vectors in the metric space, and we can calculate which chunks are closer to which peers. So we will deliver these chunks to their closest peers, and this is what my node is currently doing. So I am pushing chunks. So this is still doing. My internet connection upload speed is not so great, so this is still running, but every chunk is pushed to the peer that I know that is closest to this chunk. And if this peer knows another peer, is connected to another peer, which is actually closer, that chunk will be forwarded to the closest peer. And that way we are distributing our chunks in the network, so that our retrieval process, and retrieval process is part of the process when we download a file, our chunk retrieval will be able to find the chunk by looking at which peers are closest to the chunk. So this is a reverse process. And I'm still uploading this. So if you would like to download this this is the file that I this is the file, the address of the file that I uploaded, and when I push this chunk, you will be able to download it from the network. Okay, I would like to go into something that is and this is the BAPI reference. So this is actually storing, presenting the information about API that we have. And we use the file API to to upload a file. This is /files, and we can upload specific bytes, get specific bytes, byte array of bytes. So this is arbitrary data. Chunks, specific chunk, but this is more on a lower level. If you are a dapp developer, you can use these two as for your distributed application to implement some specific logic, because it is a lower level API. And file API is actually storing metadata about file name and content type. This is much more useful for sharing files, and even more useful is to share a collection of files. So we can upload tar file which contains directories of files in order to access them over the API. So you can see that pusher did its work. So this file is now pushed to the network, and you should be able to download it by your own nodes. So so if you go and execute something like curl oops, I forgot the files. So this is files API. File exists. Okay, so yeah, I already have the
in the chat there is one JPEG image. Maybe you can use this one to illustrate downloading a file.
Mm-hmm. Let's do that. So pasting the address of the, yeah. Okay, and yeah, so nice to see you, Attila. Wonderful. And that is a nice demonstration from attendees. I would like, so we have 5 more minutes, and let's upload a website, and let's do that without as quickly as possible. And I have here some code shared by by our colleague Dan. It is an application that can be hosted in Swarm, but it is basically a distributed application to use BAPI to share snippets. And I will just I already cloned this.
Is the repo public, Janos?
Yeah.
Okay. Yeah.
So this
is. Yeah. Thanks.
This is the and what we will do. We will tar this. And yeah, that's it. We created this site. We will this we packed this site tar. So we see files there. So it has some assets in the assets directory, index.html referencing these assets, and we can upload. I already have this not to type. So we will post this tar file. This is the tar file to our DIRS endpoint. We will set the header swarm index document to index.html. We have this index.html and we want to serve this index.html on the root of our address that we will receive. So not to be required to type index.html and share those types of links. So we already have our Nginx and web servers set up for this, but we are here explicit. And yeah, let's upload it. This is not so large. We got this address and BZZ. So we will use BZZ to access this. And if you can see in the, so I will just refresh and you can see that we are downloading our assets with this URL. So we have BZZ endpoint that can serve files under this hash. So this is a very nice application that you can use. So I actually don't know how to use it, but it is a nice presentation that it loads the required assets.
Maybe, I don't know if Dan is here, if Dan can do a 1-minute pitch of this app. If he is here, if not.
Yeah, Dan will host the second workshop, which should start right now.
Yep.
But yeah, so this is so another thing that I wanted to share is that actually we have a few demo videos, quite short, in the Ethereum Swarm YouTube channel, and you can watch that. We actually used this swarm encryption in testing a lot for testing the current release. So I don't know how much we can step into the next hour. So Rinke, should we stop here or continue with things?
No, I think Janos, this was perfect. I think we can stop here. We prepared a bit more, but I think this is all good for the next workshops. So maybe just a couple of final notes to all participants. Thanks again for joining. We hope that this was useful, and we hope that that this workshop triggered you to start looking into our documentation and read the book of Swarm, and basically become part of one of the first adopters of this revolutionary new way of building applications on top of the internet. As mentioned, as the Swarm team, we are very much looking forward to collaborate with you. Collaborating both on the software level. If you have a cool idea for an application, share it with us. But also if you just want to discuss this and maybe want to have some more philosophical talks about what we're actually building, we believe that this is also highly relevant. So definitely not only tech-savvy people are welcome to join us. Maybe one more request is the link to our Telegram channel, the Orange Lounge. I don't have it moments, but maybe somebody can join this, share this in the chat. And then, of course, we have another workshop, which I think is starting right now, hosted by Dan. And this evening, we are having the release of the Swarm Beta. So if you want to hear more about the latest features and the developments of our ecosystem and announcements, then you should definitely join there as well. That was it for this workshop. The next workshop is starting in half an hour, so take a well-deserved break. And yeah, don't see the link of the Telegram group, so I don't know, invite new members. Can I do this? No, I can't. Okay. You can also reach us on GitHub. You will have a link to GitHub, and I'm sure you all find your ways to reach out to us if you really want. So thanks again, and I hope to see you all very soon. All right.